So welcome to the part 2. Last time I believe we stopped here where we were building the creature, and we were also making all the different masks that we are going to run in the simulation and in the texture, like in the shaded in cups. So let's move on to the next part, which is the simulation. Let's just start with an object merge and bring the creature. And right now it's in quads, as you can see. Like ideally in the Vellum solver you want to use triangles. In the remesh, the target size will depend on different things. One of them is like if you go very low in the target size, let's say 0.05, it's gonna take longer to process every frame, so it's gonna be a really, in my opinion, it's unnecessary. So I like to keep it somewhere in the middle. I think, let's say 24,000 primitive, that sounds fair. I think like you will be able to get good results and also see, like, play the simulation live, at least in my computer. So let's go for this. There's not much here to change. Then now we have our mesh here, and now we get into the Vellum simulation ground. On the Vellum side, I'm gonna use 3 different nodes. One is gonna be Vellum cloth. The uniform, the mass, it's I put it as set uniform, so it's the same mass all over the geometry. And the thickness, well, the thickness, I mean, is fairly low. If you see that it's intersecting a lot, you can take this one higher, so it avoid, you know, especially if you have a collision geometry, like an external collision geometry, then you can play with this to prevent the collision to intersect, like the geometries to intersect. Other things like the stretch and the bend stiffness, well, these are the values that work for me. I think by default it's like this. So I went a bit higher, so it's a bit more stiff. It doesn't bend that easy. And this is all I change here in the cloth. Then we have the pin. And for the pin, we prepare before a mask called mask pin. The reason is that I wanted the creature to be like to stick in one place, like to be still, that it's not moving around or bouncing around. So I created that mask for this purpose. And to use it, I just use this expression here in the geometry group type points, because it's a point mask. So I call it add mask underscore pin higher than 0.1. And this is gonna then select points in that range. If I say, for example, 0.9, then it goes lower and so on. So this will stick, it will create a pin on those points, and it will keep the geometry in that place. Then we add the strut, or I think that's how you say strut. This is what's gonna give you the soft body feeling on the geometry. You can just make a Vellum constraint, right? And then the Vellum constraint on the top, you change the constraint type to struts. And here, in this case, for this example, I only changed the rest length, and then I went a bit low in the multiplier here of the stiffness. I'm gonna go more in depth about the rest length. Let's just say that you can leave it to 1, and that's fine. And then just play with this value here, the stiffness, regarding the rest length, right? In this example, in the part 1, when we created all of these different masks, they serve like different purpose, or 2 purpose, let's say. One is to use them in the simulation, in the Vellum simulation, to derive some Vellum attributes to do specific things. And the other point of this attribute is to use it in cups to derive then textures into those areas, like to use, like for example, let's say, yeah, the body to run a different, specific color or feeling in that area. So that was the whole point of that. Now for this part here, for the vellum, right, I'm gonna use these three: the mask ring, mask noise, and the mask body. And to be able to use these attributes in my vellum solver, I need to convert them from point to primitive. When I do that, I'm gonna combine these attributes. And what this node allow me is to combine all of these different attributes into one. So in the destination, I'm gonna say, I want these three different attributes: the mask ring, the mask noise, and the mask body. I want them combined into the mask rest length. And the result of this is that all three are combined. We have the noise taking effect here, you see this, and then the ring, which is moving up and down, and the body, which is the tip of the creature, right? You can try different. Right now they are adding on top of each other, but you can of course subtract and then or do different mathematical operations to get different results. There is an overscale here, which is just a multiplier. So once we have combined this attribute, I'm gonna add an attribute remap. Currently, if I look at the mask rest length, let me stop here. If I go to the primitive in the geometry spreadsheet, right, the values are going from 0, minus 0.7 to almost 2. The reason why I'm doing this remap is to control the rest length. A value of 2, for example, is way too much, so I try to keep it very low, so it multiplies like very low, so it's much easier to get the result that I was looking for. So once we do this, the remap and all that, we need to transfer back this attribute. So I'm taking, and we're gonna do this in the constraints. So I'm gonna use an attribute transfer, where I'm calling on the left input and the first input, I'm gonna use the constraint, and the second one I'm gonna get where the attribute live. I just look at here in the primitive, and then inside in the vellum solver, I'm using 5 substep. You don't have to go directly to 5 substep. You can start with 2, and then you can go higher as you get the result that you want. So in the vellum solver, I have the 5 substep. I'm starting the simulation in the frame 990 because I'm expecting that by frame 1001, I'm gonna start rendering from there. When I go inside of the vellum solver, I have added these two nodes. One is a subsolver, and the other one is a vellum constraint property. I'm gonna start with the vellum constraint. The vellum constraint property, basically what I'm doing here is I'm checking the rest length so I can edit this attribute, because here in the vellum constraints outside of the solver, I cannot run an attribute in the rest length compared to this, where I can use an attribute. I cannot do it here for any of them. For the stretch and the bend stiffness, I cannot modify it. I can only use the multiplier. So inside in the vellum constraint property, I can do that. I can then set it, okay, I want to play around with the rest length and the scale, and then what I'm going to do is like say the rest length, right? This let's say parameter here is called rest length. You can see there how it's written, rest length all together. So I call it here. I type it down here and use this Beck's expression, and then equals to mask rest length, which is the one that we did before, the one that we combined here, correct? It's this one that is coming through. I'm just telling this, hey, this value, this parameter here, I want to be driven by this mask here. Okay? And what this rest length scale does is a multiplier. Okay, so whatever value you have here, this will multiply by, I think by default is 1, and then you can go higher or less, so it will have a different effect. If I go, let's say, lower, this is what happened. It shrinks. If I go to 1, for example, then this is the value that we're running right now in the remap. And again, these are not like straight values, but at the time when I put these values and then I came back here and say, okay, by 2, let's multiply this by 2, I got the result that I wanted. So it could be that you can find better values here. Let's say remove 1 0 for each one of them. And then we go back here and we go to 1. Then something should happen. You see, it went crazy. So this is the kind of thing that I will expect you will probably experience, but with a little bit of patience and, you know, tweaking around, now we are back. So we went from 2 multiplying 2 to 0.2, and then up here in the remap, I just removed 1 0 for each one of them, and then I got more or less the same result as before. So I hope you can see this, how these connect to each other, because it's gonna make a big difference in your experience while trying to find the values that you want. So I'm gonna leave it like this for now. I like this. Now, what is the subsolver doing? If I don't use a subsolver and I catch all of this, the problem that I'm gonna have is that all the animations that I have in the masks, in my mask here, all of this stuff, the ring and all this stuff moving, you see? If I don't use a subsolver, the Vellum solver is only gonna use the first frame of those animation. So it's not gonna move. It's just gonna be still, like, you see, nothing is happening. At this point, the ring should be moving. But when I connect the subsolver, and I'm gonna go in a minute, then it's gonna, for every frame, it's gonna read the mask animation, and it's gonna be like, okay, in this frame, the values are these. In the next frame, the values are this, and so on. So in every frame is gonna read this mask, animated mask, and it's gonna solve it or apply it in the solver. So in the subsolver, what do I have? I brought the null that I have here, so the geometry with the mask, right? I just call it here, and then with an attribute copy, I will then copy the mask rest length as an attribute class primitive, because it's a primitive. You get a little warning here. It's just gonna say that it's gonna be slow or something. Yeah, don't worry about it. Here I had this was just another thing, don't worry about it. And so basically now I'm running the mask on every frame thanks to the subsolver. So it's solving the mask every frame and passes that information through the Vellum solver. And this is the result that I got. Then you know, now that's the mask moving up and down, and the noises and all that stuff. So if you have managed to get to this point and be happy with the result, congratulations. I'm gonna warn you again, it can be a bit frustrating to find the right sweet spot that you want, but it's doable. It's just a matter of playing around with the remap, playing around with the values in the class and the cloth and the Vellum constraints, and also in the rest length, like the multiplier, like finding a balance between all of these three, you will get something that you will like. So if you got the result that you wanted, catch it. I typically use Vellum IO. I like to use this one because then here in the Vellum post process, I can fix stuff like detangle, like smooth, and correct some collision problems, or even blur a little bit to maybe some undesired geometry deformations. You can also subdivide all of this stuff. So that's why I like to use the Vellum IO. Now that I have my geometry cache, I'm gonna delete some mask that I don't want, some stuff that I don't want, and I'm only gonna keep the mask that I do want, because the Vellum solver is gonna create all of this stuff and you don't need any of that. Or well, you could use it, but I'm only gonna use the mask that I created. Therefore, I'm telling here, okay, delete everything with this asterisk here, and then with this symbol here, everything except for the stretch ratio that I'm gonna use later, and everything that starts with mask underscore. So everything that start with this, whatever word it's after, is gonna keep it because of this symbol. So now we have the Vellum simulation. Let's move to the next step.